$90 million for a project that had to be finished in just 6 weeks, all to protect 30,000 people and a power plant worth over $2 billion. This wasn't just an engineering race, it was a full-scale war between man and nature. Hundreds of engineers had to scramble to stop a massive flow of lava, burning at over 2,000 degrees Fahrenheit as it spread further every second. So, how did they pull it off? Follow us to find out the secrets behind this mission, and don't forget to hit like and subscribe if you're into projects that push the limits like this. When the alarm was triggered on the Reykjanes Peninsula, where the Sundhnúkur volcano has been erupting since late 2023, the entire area went into a state of national emergency. Iceland wasn't just dealing with a simple volcano. They had to defend entire neighborhoods, tourist spots, and critical infrastructure as lava, reaching 2,000 to 2,200 degrees Fahrenheit, headed straight for them. The mission was to launch a disaster response operation at a speed never seen before, building specialized walls to redirect the lava before it could wipe out everything in its path. To get it done, Iceland mobilized a force of hundreds of engineers and workers, pulling 12-hour shifts, 7 days a week, right in the middle of dangerous terrain and extreme heat. They stuck to high engineering standards from step one. High-tech caterpillars were used to rip up the thick rock layers underneath to prevent the lava from creeping through any gaps below the surface. Next, giant dozers leveled the ground to make sure the soil layers were tightly bonded. Excavators then grabbed massive boulders to use as a heavy-duty structural core. After that, the wall surface was covered with fine gravel and volcanic ash, or tephra, to seal every crack, making it nearly impossible for the lava to burn through the structure. During the most critical phases, they brought in a massive fleet, over 100 dump trucks hauling local basalt boulders. Around 40 heavy excavators, ranging from 30 to 50 tons, were used to build the backbone of the wall. In the hottest spots, or where the lava was expected to hit first, the engineers worked at a blistering pace to stay ahead of the flow. At one point, the team was moving about 200,000 cubic yards of material every single day. This allowed them to raise the walls by about 7 feet every 24 hours, just moments before the lava reached them. Construction was fast, but quality was still the name of the game. Every wall erected had to meet brutal engineering standards. These barriers were designed with a strategic height of 25 to 33 feet, and in low-lying areas where lava could pool deep, they pushed that height up to a maximum of 55 feet. The key to the design is a massive 130-foot wide base with a trapezoidal cross-section. The slope is set at about a 1 to 1.5 ratio to maximize gravity stability, ensuring the wall stands its ground even when molten lava is pressing right against it. It's estimated that a single yard of this wall can withstand thousands of tons of pressure. In an emergency like this, a critical 4-mile section of the wall, made from over 4 million cubic yards of rock, was finished in just about 6 to 8 weeks of nonstop work. At the most vulnerable spots, with crews and machinery running 24/7, mile-long sections were put up in just 150 hours of continuous labor. That is a staggering pace in the history of volcanic defense engineering. Now, a strong structure is a must, but knowing exactly where to place that wall to stop the flow is where Iceland turned to supercomputers. Every single wall placement was based on results from the VSC, Volcanic Simulation Code. Engineers use LiDAR laser scans to create topographic maps accurate to the centimeter. The computer then ran hundreds of eruption scenarios from different issues. This engineers allowed to pick choke points in the terrain to build the walls, optimizing the amount of material used while still being able to pivot the flow at a 30 to 45 degree angle. This trick reduces direct pressure, letting the lava slide along the wall instead of knocking it down. From the simulation to the brutal reality on the ground, the factor that decided the survival of these structures was the material's ability to stay inert under destructive heat. Ditching concrete was a smart engineering move. At temperatures between 2,000 and 2,200 degrees Fahrenheit, concrete will actually explode, a process called spalling, because the moisture inside turns to steam instantly. Instead, the Icelanders used solid basalt, the very rock formed by these volcanoes. With a melting point over 2,300 degrees, this rock is basically immortal when it meets a fresh lava flow. This rock-fill structure provides geotechnical flexibility. It allows heat to escape efficiently and lets the wall self-adjust its center of gravity if the ground underneath deforms from the heat, all without cracking like concrete would. The combination of speed, tech, and rugged materials delivered a result that was vital for both energy security and the economy. With a total price tag of about $90 million, this stands as the largest and fastest volcanic defense project in modern history. That investment successfully saved the Svartsengi geothermal power plant, the literal lifeline for 30,000 people. During the 2024 eruptions, the lava rose right up to the edge of the barrier, but just like the script predicted, it was diverted away. Even though they couldn't stop new fissures from opening inside the town of Grindavik, the system overall saved the national energy infrastructure from total destruction. The Icelandic engineers proved one thing: when we truly understand the laws of nature and respond with precise engineering at record speed, we can set safe boundaries to maintain life right next to the most aggressive rivers of fire. And after those intense moments, they get to relax like this. Looking back at Iceland's achievement, I think it would be interesting to compare it to another Great Wall of the 21st century, Japan's 250-mile tsunami wall. While Japan spent $12 billion in nearly a decade casting a permanent fortress of reinforced concrete, Iceland took a completely different approach: fast, cheap, and flexible, with a price tag of only about $90 million. The difference lies in the nature of the enemy. Japan faces tsunamis. They need the hardness of concrete, deep foundations, and automatic floodgates to take a direct hit, breaking and scattering the wave's energy. On the other hand, Iceland faces 2,200-degree lava, a temperature that would make concrete explode instantly. So instead of a dead stop, the Icelanders used local earth and stone to go with the flow, skillfully steering that hellfire towards safety. However, whether it's a $12 billion concrete wall or mounds of rock put up in a few weeks, both nations share the same philosophy: humility before Mother Nature. They understand that humans can never stop a disaster 100%. Japan builds walls to cut the water's power by 50%, and Iceland builds dikes to buy time against the lava. The ultimate goal isn't to defeat nature, but to win a few more precious moments. And in those life or death situations, a few minutes or hours is the thin line between survival and tragedy. That is the story of how man uses engineering to protect life. Thanks for watching, and don't forget to hit like and subscribe to join us as we explore the next great mega project.